Good day, we are Team 6 and we will present the Pymol program. Pymol, it is a high-quality molecular structure weaver. It produces render scenes, animation, and interactive visualizations. Works with small molecules and biological macromolecules such as proteins. It also visualizes molecular trajectories and crystallographic or orbital surfaces. Pymol is a used expansor molecular visualization system and open source foundation maintained and distributed by Strödinger.
To download the Pymol program, you must have a license, and for this we must enter the official Pymol page and click on New User. We will click on the Student Teacher section. To register, they ask us for information such as our name, name of the institution, email, telephone number. It is important that we register as students science for educational purpose. It is free of charge. The name and password for the license will arrive at the email we register. Click on the link and it sends you to a page, and click on this link to download the license. Later we go to the main page and click on Windows or depending on the operating system. Click on Run. And follow the subsequent steps to finish the download. Once the program is downloaded, we look for it and open it. A tab will appear to activate the product. Click here and another tab will appear to select the license file. Click and it will appear as active for educational purpose.
Once we finish downloading this program, we're presented with this screen with 5 main sub areas. The first one being the toolbar, where we have different set of tools that can help us with the file that we're working on, such as the file toolbar, where we can open and export and log our activities, the edit, the build, the movie, the display, where we can customize the way we view our protein, the settings, the scene, the mouse, and those type of things. We then have the commands that are generated automatically with this program. Whenever there's a change or a significant change in this protein, it would be logged, and we will be able to see it on this area on the command. We then have the view toolbar, which is pretty much based around the way we view the protein. It's not really that important. Then we have the commands, which is one of the most important things in this program. The commands that we can apply to the protein itself. And I will go into detail in a bit. But before that, we have, well, basically the most important part, the visualizer. which is the part where we actually use to visualize this protein. Now, to properly view this, we have to use our mouse to the best we can, using the left click to rotate it around. We can either rotate it horizontally or vertically at a pretty much 360 angle in any degree. Then we have the right click, where we can have a zoom in and zoom out. Honestly, the capabilities of this are quite interesting. You can zoom in pretty far in. And then we have our little mouse scroll, where using this we can actually change the layers that we actually see. In this case, we are removing the top layers. So in this case, we won't see this part of the protein. It will actually vanish, so we can see the parts in the back. These being the parts that we wouldn't normally see with everything else in the way. So that's about the visualizer. And then we have the commands, the basic commands. A standing for action, which is the basic actions that we can take, like zoom, centering the protein, the origin. We also have presets, but we'll be back in that. Show is, well, basically the capability of showing different things. This goes in hand with the H, which is hide. In this case, we can hide the cartoon and we won't be able to see much of the protein. But if we show the cartoon, we will see it this time. We also have label. L for label, which this is the part where we can put a name tag on most of the things. Like we can put a name on the atoms that we have, or we can clear them and we can put the residuals that we have. Obviously, we can work this in layers. Selecting this via the display in sequence, we can select a variety of amino acids, and whatever we select will be in a certain layer, just like Photoshop. So this layer will only work on this area. So we can even color it so that simple strand can be identified. And well, not only that, we also have commands like Control Z to undo and Control Y to redo. Anyways, once we have this part selected, we can also label the residuals, and this time it's much more clear as to where we are working with. Anyways, so that's pretty much it for the functions of the program Pymol.
To visualize a protein in Pymol, we need to look for its structure. Where can we find it? Well, in databases dedicated to proteins. To download the file, we are going to enter Protein Data Bank. In the research engine, we type PDB. And select the first option. Now we will see the homepage, and practically we have to Protein Data Bank is a resource for finding 3D structures of proteins, nucleic acids, and complex assemblies such as viruses. At the top of the page, there is a search engine. Type the name of the protein of interest. We look for thymidine phosphorylase. Right thymidine phosphorylase and click on search. And we go down from the results obtained. We choose the one that meets the specifications. For example, we want to visualize the thymidine phosphorylase of Escherichia coli. So we select the first option because the organism is E. coli. Then we go to download files and download in PDB format. Is complete. Now we enter Pymol, click on File, Open, and select the file .pdb. We can look our protein, thymidine phosphorylase.
In conclusions, the program's Pymol is very good because this program helps us to visualize the proteins in 3D and to go deeper into it because it is very important to identify the points where the atoms, nucleus, etc. are located. A show is in this simulation where see the protein and the conformation of the proteins, which are the amino acids. The proteins we are working on is thymidine phosphorylase, which is an enzyme involved in the metabolism of nucleotides and of the great interest in angiogenesis and is the correlation with the aggressive development of tumor process.